Good afternoon. Today we'll see another method of analyzing an electrical circuit. The method is mesh current method. The basic objective of this particular method is to find out current flowing through a particular circuit element or voltage drop across particular element or power consumed by that element. So let us define the problem statement like this one. For a given circuit, calculate current flowing through 6 ohm resistance using mesh current analysis. So what are the previous method we have covered, that is the branch current method, and this particular method, the basic difference is in branch current method we have assigned different currents for different branches. Whereas in this particular method, we are assigning the loop currents or the mesh currents. So if we look at the circuit, then there are 3 loops. So I will name the loops as loop 1, loop 2 and loop 3. Now I will assign the loop direction at the same time a loop currents or the mesh currents. So I preferred the clockwise direction. Now for loop 1, whatever the current is there, I will take this current as I1. For loop 2, I will take current as I2, and for loop 3, I will take the current as I3. Now for a mesh current method, again we have to make use of Kirchhoff's voltage law. So if we recall the statement of that law, what it says is algebraic summation of potential around the closed path is equal to 0. Now in order to apply the KVL for these 3 loops, we will make use of a method of inspection. That means in a short time I can write the loop equations. So what we have to remember here is the 2 terms. One is called as self resistance, right here, self resistance, and another term is the mutual resistance. Now the meaning of resistance is the resistance of that particular mesh or particular loop, whereas the meaning of mutual resistance is the resistance which is common between the different mesh or different loops. So if you look at the circuit, for mesh 1, 2 ohm and 8 ohm are the self resistances. For loop 2, 8 ohm and 4 ohm are the self resistances, whereas for loop 3, 6 and 10 are the self resistances. Now between loop 1 and 2, this 8 ohm is the mutual resistance, whereas between 2 and 3 there is no resistance as such. In that case you have a simple battery of 20 volt. Now when I am applying KVL to these loops, what I have to do is, so I'll start with the loop 1. So if I apply KVL to loop 1, now here procedure is look at these self resistances. Now here self resistances are 2 and 8. So that total resistance is 2 plus 8. Now its voltage drop is loop current that we are assigned is I1. So 2 plus 8 into I1 is the voltage drop across that self resistance. Now the mutual resistance is 8 ohm. So if you look at the current directions, I1 is the current that is flowing down, whereas I2 is the current that is flowing up. That means whatever the drop across 8 is there, that is minus 8 I2, since I1 and I2 are flowing in opposite direction. So these drops across the resistances because of the 2 different currents I1 and I2 is equal to this drop. That is nothing but the battery potential. Now here thumb rule is, when I am equating this drop to some value, so the battery is nothing but the 10 volt. But when I am finalizing the polarity of the battery, the thumb rule is, if this battery forces the current in a direction which is same to that of the loop direction. See, for this loop, we have assigned the current I1 and current delivered by the battery. Now, since the upper terminal is positive and lower is negative, current delivered by the battery is again in the same direction. So that's why when I am equating this drop, then I have to take the term, take the sign plus. Are you getting this one? I will repeat one more time. When I am equating these drops to a battery potential while finalizing the polarity, the rule is if the battery delivers the current in a same direction to that of the loop current, that drop is positive. Against this, if for example, if your upper terminal is negative and lower terminal is positive, then this positive terminal will give the current. That means in that case, battery current and the loop currents are in opposite directions. So in that case, I have to take that drop to be negative. Okay, so this is your equation. So if you simplify, it is 10 I1 minus 8 I2 equal to 10. I will write this to be equation number say 1. Right. Now if I apply KVL to loop 2 now. So if you look at loop 2, now what are the self resistance is there? It is 8 and 4. So corresponding voltage drop is 8 plus 4 into I2 is the current. So my drop is 12 I2. Now here mutual resistance is 8. And again if we look at the direction, I2 is flowing up whereas I1 is flowing down. So whatever the voltage drop is there, that is minus 8 I1. So again if you check the voltage drop because of the battery. Now this battery upper terminal is positive, that means it is delivering the current in upward direction. The loop current is clockwise in a downward direction. That's why when I am equating this, there should be a minus sign, so minus 20. So the equation is 12 I2 minus 8 I1 is equal to minus 20. So let this be equation number 2. Are you getting this one? Now I have to apply KVL to third loop. So when I am applying KVL to this loop, now the self resistance is 6 and 10. So your resistance is 6 plus 10, that is 16, and current flowing through this third loop is I3. So there is no mutual resistance between mesh 3 and mesh 2, simply battery is there. And once again if you check the polarity of the battery, upper terminal is positive. That means this battery is delivering the current which is in a same direction to that of loop 3. So that's why whatever your drop is there, that drop is plus. That means your equation is 16 I3 is equal to 20. That means for a given circuit, we have 3 loops. So by using the mesh current method, we got 3 equations. Equation number 1, 2 and 3. Now when we are solving these 3 equations, our problem statement is to find out current flowing through 6 ohm. Okay, that means if you look at the circuit, I6 ohm is nothing but I3. Okay, now since 3 equations are there, I can use either Cramer's rule or I can use direct calculator for finding the loop current or for finding the current flowing through 6 ohm resistance. Right? So you can use any method. So after solving these 3, you will get I6 ohm is equal to 1.25 ampere. Now, since the answer is positive, get the point, final point. Since the answer is positive, whatever the current direction we have assumed is same. That means that current direction is okay. So my final answer is current flowing through 6 ohm is 1.25 amperes from left to right. Or if you put some letters here, say AB. So in my final answer, I can write the current from A point to B point. Okay.